All right, this is what we got cooking today. We're gonna start into assemblies, so that's good. But you have one other modeling project. I called it the IC project. That's the individual choice project. You get to choose what you model, something from your house. So if we look at that, I can show you a little more detail. So you choose it, this one right here. Choose any object at home to model. Measure it best you can. If you have to estimate the size, that's fine. If you choose something difficult, you're going for full credit. If you choose something super simple, then you're going for 80% credit. And I get to decide what's difficult and what's not. And let me tell you, what's difficult for one person might be easy for another person. And I get that by now. So use your own modeling experience and choose something. Difficult things are things like forks and spoons, believe it or not, are quite difficult. They have no straight lines. Okay, now if you build me like a straight fork, well, that's, come on, don't do that. But you can find simple things like, containers that you take your lunch in, probably is fairly simple. Most things are not just straight lines though. So really look at what you're going to model and pick carefully. Don't pick something too hard. Pick something challenging for yourself. It can be an assembly or a part. You haven't done assemblies yet. So if you choose an assembly, choose that super carefully. You could model a piece of furniture as long as it's simple. Because I'm going to do a desk today. Just a very basic, simple desk as our first assembly. And then you're going to do it. So you choose. You got a week for it. Good? You're going to make a drawing of it too, so make sure you read the assignment carefully. If it's a part, you just model it up, right? This would be fairly difficult. I mean, there's a lot of cutting. It's pretty straight line stuff. So this is not super easy. You look at it originally and you're like, oh, that's pretty easy. Especially if you try to figure out how to add the knurl to the part that you grab. That's difficult. It's got a lot of cuts. It's getting on the easy side, but so my difficult is not hot crazy. Just don't go nuts. You shouldn't put like 10 hours into that part. That's too much. Okay. All right. So that one's due on the 20th, and then we're going to do the table. Our first assembly. Questions? A week from today, we'll have an exam where you'll just have to model a part and make a drawing from the part. Okay. That's it. The part is not difficult. I guess what's difficult is just getting it all just right. And then creating the drawing and making that look decent. So we haven't done a lot of drawings. You're going to do 2 more sets. So any questions on drawings so far? Such an easy group. Man, piece of cake. All right, well, let's talk about assemblies. Oh, I just did the mouse. That was a bit of a pain. Did you all enjoy the mouse? Not me neither. Like, what is happening? I ended up just modeling it the way I thought I should, and I stopped following their directions. It's like, I got a little confused in some spots. So, like, they're making planes where planes already exist. So if you're not going to the front, top, and right plane often, I think you're modeling incorrectly because those already exist. And if you set this up correctly, then the front plane was like right down through the middle. So I didn't need to make a new plane when they said make a new plane. Like, why? The front plane's right there. So you don't have to make new planes over and over and over. You can actually use the front, top, and side planes over and over and over if you can, right? So, yeah, anyway, good job for fighting through it.
I ended up using the shell because I couldn't figure it out.
You can't do that. It didn't say shell.
I know, but
There you go. If I give you like directions, you're going to go some other way. So I should just not. No, it's fine. The other thing I don't like is it's not a solid. It's a surface. I'm like, what are we going to do with that? Like, we can't even 3D print that. Anyway, it's all good. All right, let's talk about assemblies. So there's, oh, that's a mistake. I want to sweep, I want to go founder. Assemblies are here. Way we're gonna make assemblies is we're gonna make the parts first, and then we're gonna pull the parts into the assembly. Okay, there are other ways of making assemblies. You can go straight into assembly and then start modeling parts inside the assembly. It's more complicated to do it that way, a lot more complicated. After we do it this first way, I'll show you the way to model inside of an assembly. But you really have to keep track of, because it's like running the part software inside of the assembly software, right? So you really have to like keep track of this area over here and keep track of whether you're in a part or assembly. It's just complicated. So we're gonna start simple. We're just gonna model the parts. So I'm gonna start with part. I'm gonna get rid of this. I'm gonna maximize, oh, that. All right. So down here on the right, just as a reminder, is your metric US choice, right? Right down here. So make sure you're in the right space. This is in inches. It is on page 222. It's this table. Pretty simple table. Okay. I added a top to it, so make sure you read the assignment when you go to do it. But you're gonna make this. It's got vertical legs. That's one part. Okay, it's just repeated 4 times. It's got these top outside pieces, the long, I think they call it short side and long side. So it's got these long sides. That's one part. Again, 4 times. Does that make sense? Yep, okay. So that's the way we model, is if you're gonna use something over and over, we just make one part. And then when we do the assembly, we'll pull it in 4 times, or we'll pull one in and make an array of it or something like that, okay? There are 2x4s, which measure 1.5 by 3.5. And then we have lengths. Short side is 39. The upright or verticals are 48. And then 75 with 45s on both sides. Pretty simple, like rectangle, extrude, done, right? I made them pine, so I do want you to give them material, so I added that. And I added the pine top, which you can read about. So, all right, let's do this. This is a good one for me to demonstrate because you can sketch the stuff pretty easily. I'm going to try and keep things in position. You don't have to. You can model things in any position you want. When you pull them into the assembly, they're going to come in the position that you make them. So you're building some ease into the assembly if you put them in the right position. Okay. So I'm going to do that upright first. And I'm going to use the top plane and I'm going to draw a little rectangle and then extrude it. And it should be in the correct position. So just making a part, you can all do this as easy as I can. What was the upright, 48? Yeah. So that's a part, right? I said it's going to be pine. It is a lot easier to set your materials as you go. So I'm going to add that material and go into wood and find pine. That even makes it kind of pine color, right? So when you get your parts made, you want to save them. Since we're heading for an assembly, you want to make a folder for it and collect all the parts in that folder. Don't just randomly put them somewhere. We need to keep these things together. I can't see your assembly unless you send the parts with it, which I gotta have the parts. If you send me just the assembly file without the parts, I won't be able to open it. It actually shows it to you for like 20 seconds while it's looking for the parts, which is kind of weird. How does it even know what it looks like? But it does. And then it says can't find the parts and it just stops. Okay, so we have to have some strategy here. I already did this once, but I'm gonna name it something else, create a folder, and I'm gonna say table in class. Right, so I made my folder, and then you want to name your parts pretty descriptive. So they called this an upright, so I would call it a 2x4 upright. And then I would put the length in, 48 long. So I can use this part for a lot of different things in the future, right? Not just this table, but if I needed a 2x4, 48 inches long, I have the part and it's named where I'll remember what it is, okay? So name them fairly descriptive when you do your assemblies. Don't just name them top piece. What's that? Right? Give it some description. All right, so I'm gonna save it. And I'm gonna make one more. Well, maybe I'll make all three. So a new part, again. So that part, it just stays open. I didn't close it, right? I just left it open. Sketch. And I'll do one of the shorts. How long is a short? 2039. You have bad eyes. All right. Rectangle. Any questions while I'm doing this? You can maybe multitask. Yeah.
When you're making an assembly, and you're trying to signify like connection, like for example, the table, do you have to model the screws if you want to put them in the screws?
So not typical. So modeling intent or modeling strategy in most places, I can't answer for all locations. If the item can be purchased off the shelf, we don't typically model it, right? Unless we're trying to figure out access, like if it's a screw and it's a pre-drilled hole, and I want that pre-drilled hole to be in the part, then I would put that in. If it's not a pre-drilled hole, it's just a screw gonna put two things together, we can put fasteners in without having to draw a screw. Just place a fastener. Okay, so there's good reasons to put fasteners in your assemblies because it'll keep track of them. Like in the end, you could query it, how many 2-inch screws are in this assembly, and it would just spit that information out. And you'd have an idea of what materials you need. So, I mean, there's reasons for putting them in because it looks good, but there's other reasons like don't waste your time because you're just gonna go buy that thing anyway, so. Yeah, anyway. All right, I'm gonna set the material to pine. Steel is always open. Don't know why. Does this one have the angled corners? Short side? Yes, it does.
45.
Yeah, so just be careful. These are 45. They have angled corners on the short side. 39 long, point to point. The upright didn't have any angles, but then the long side also has these 45-degree chop offs. So I gotta chop that thing off,
So you use frame on it,
huh?
you use the tool frame, this one.
For chopping it off? No, I'm gonna cut it. Yeah, so I'm just gonna go this side view. And I might set a plane first because so my modeling intent is, I should be telling you this. I'm gonna chop off one side and then I just wanna mirror that feature to the other side. But when you're in 3-dimensional like this, to mirror a feature, you need a plane to mirror about. When you're in sketch, you just need a line to mirror about, right? Because sketch is all 2D stuff. When it's 3D, it wants a plane. If I don't put it in now, it's harder to pick the 3 points for the plane, right? So I'm gonna forward think and say, okay, I want this plane in now. Oh, gotta get out of sketch. Didn't forward think quite far enough, did I? Plane. So then I can go and say, okay, I want the midpoint of my part. It found it right away. I'll just accept it. And it won't let me. Okay. There's the other one. And there's the other. Now it'll accept it. So I do that first before you make the part not symmetrical, because it's easier right there. All right, now I'll chop it off. Nope, don't want that. So that plane was selected, right? I don't want that plane. So when you hit sketch and something's selected, it chooses it. All right, I don't want that. So I hit escape, get out of sketch, make sure nothing's chosen. And then go back into sketch, because I want to sketch on that surface. Zoom in so I can see nicely. Sketch up my triangle that I'm going to use. Carefully grabbing those points. Smart dimension this angle at 45. Right? So that's going to chop it off. Extrude cut. It's probably going to go all the way through. It looks like it is. Done. Okay. And now I just want to take that feature, which is the extrude cut, and mirror it over here. So I don't have to make it again. So that is under features and then mirror. And it shows you got to have a plane, right? Can't just mirror features without a plane. So mirror face plane. Features to mirror. I want this cut. So remember, your history tree goes here. I can open it up and then go down and choose that cut. Okay, that takes a while for students to realize that your history tree just moves around. It's always available. Okay, so it's easiest just to go grab the cut. Boom, we're good. We're gonna save it. I think this is 2x4 short side. And it is 39 long. Yeah. 2 parts. Good. All right. One more part. This will be the long side. So I'll try to sketch it in position by using this side, this right plane. Again, it's feeling repetitious, I know. Uh-oh. I might have made a rectangle by accident there. Let's see. This one have the 45s on it too? Yeah. How long is it?
48.
No, 75. Good try. You're trying to mess me up. Set the material to pine. And chop off the sides. Oh. Again. Did it again, did it again. I'm gonna cut for me. All right, save. And this one will be long side. $75. Yeah. All right. Now we have our parts made. There's only 3 parts, right? So we can say file, make assembly from part, and it will start an assembly from this part. You could also just say open assembly, but you would get no parts to begin with, okay? So either way works. I'm gonna say make assembly from part. It's trying to do it. It's coming. You gotta be patient. Notice what it says at the very top, the little name of it. Assemb1. It's kind of like part 1, but now it's assembly 1. And it has a part attached to my cursor. I don't know if you can see that. The cursor has a little part symbol attached to it. So that part is there. All I have to do is click and in it comes. Okay? So it's not in the perfect position. It came in like that. It's I think the long side, right? Yeah. All right, so in here, when it comes in, it's locked. You can't move it around. So I'm trying to click and drag it. So in assemblies, you can take the parts and click and drag them. This one, the first part comes in locked. All right. So that's the first thing you need to know. This looks different because it's an assembly. And then this is a part. So if I open it, you'll see the history of the part. Okay. So in assembly, we see all of the part information. That makes sense? Kind of? All right. So then there's like, these are all different because I'm in assembly. So in the assembly tab, I can insert components. So I'll click that and it'll show me the available components because they're open. I left them open. If they were closed, you'd have to go browse for them. Does that make sense? So when you build your parts, if you know you're going to get to assembly, you have enough time and all that stuff, leave them open. Because then they'll be right there and you can drag them in. Okay. Look at my mouse. I must have left it open too. I could drag it in. That would be awkward. But I'm going to pull the upright in. So I just click and hold it. Pick button. I'm just holding it down and I drop it. So that comes in. Now this should be free. So I can grab it and drag it around. This one, nope, it's locked. So if that's annoying, you can right click on it and say float. Okay. I don't like my parts locked down unless I have motion. If I have motion, then I need something locked down or else everything's just going to be moving all over 3D space. And I don't want that. Okay. But this I would float and now it will move around. So now I can really like, oh, well, check this out. I can move around. Now you're moving around in 3D space, which is kind of weird. It's hard to like, it's very hard, especially when you like do this and then you go like this and you go like this. Pretty soon they're like 4 miles apart because you don't realize you're moving it at a depth. So I do move them around to kind of get them close, but then I do roll it around to see, okay, that's nice and close. That's good. Right? So now, and we can just keep pulling parts in, but we have to have a way of bringing them together so we know what they are. This is the upright, right? Yeah. Yeah.
Isn't there a way to orient it so that it was up, down, left, right?
You can always go back to this, but this will just get complicated, right? Just gets really, you can't figure it out. So
There's an indicator.
you have to be able to bring these things together. So if that's an upright right here, and this is the long side, right? What I want to do is I want to take that surface right there, and I want to put it against that surface right there. Does that make sense? Just want to rotate, it'll rotate and put it there. The way we do that is called mates. We choose surfaces to bring together, we mate them. Or you can bring edges together and then the motion would still be there like a hinge, okay? So in assembly, mate is like your best friend and your worst friend because it'll do crazy things. And you can blow things up by over mating, but I'll show you how it works. Mate, it's really simple. I'm gonna grab that surface and that surface, and then these are the possible mates I can do, and it shows coincident, meaning make these two surfaces match up. Okay, so I'll roll it around and say, oh, maybe that's what I want. Looks like they're kind of matching up. Right, so I'll hit check. And now I have less freedom of movement because those two surfaces are mating. See what it's doing? I can move it up and down still, kind of, because nothing's locked down. And I can move it side to side, but I can't move them apart. So those two surfaces are mated. Yep, good. All right, the next one I'd do is I'd take that edge and this edge and mate them. Notice mate stays open. That edge and that edge. Now I have less freedom. I can move it up and down, but I can't move it in and out. They're kind of stuck to each other, right? Check. And I think it's all the way to the top. So usually it takes 3 mates to lock, you have 3 spaces, right? 3-dimensional space. Usually takes 3 to lock it down. You're gonna want them locked down. So now I'm gonna take that edge and lock it down to that edge. And now it is locked up. I can't do anything, they're stuck together. Good? All right, that's how it works. And then it's just a process of insert. Okay, I need another long side because I'm just going to build this whole side. Bring it in. Hey, come in. Go through the mate process again. That surface with that surface. It's funky. Oh no, that's right. That edge with this edge out here. Coming into position. I'm not sure they give you a dimension on where this goes down here.
24 inches.
Really?
Isn't that part of it right in the book?
Oh yeah, I see it, 24 inches. So the way to do that, is it from where to where? Top to top? Yeah. So the way to do that is within mate. So what I'm gonna do is I'm gonna mate the top surface with the top surface, and it's gonna slam them together, right? But then I have an offset I can put in right here of 24. So that's a surface to surface mate with an offset. I'm getting it. Yeah? This is how I want you to do it. This is the first way of modeling. Just pull the parts in, try and get them in position, right? You're gonna need to build the top. So I added a top and then pull it in and made it with the top, but get everything just right. All right, let's go through saving because saving's a little unique. With an assembly, I want you to use pack and go. Pack and go. It's gonna pack the assembly, all the parts, and put it into one nice little package, and then you can go with it. You can attach it, email it, whatever, right? It's a good idea to pack and go to yourself. If you want to work on it somewhere else, then you have everything you need. If you just save the assembly, the parts might not come with it if you don't remember to send the parts, right? So it's by far the easiest thing to do, pack and go. Oh, it wants me to do a save. That's probably a great idea. Table. And it's going in the table in class, so good. All right, now I can pack and go. So it's gonna list the parts. They're already checked for me. That's good. You have 2 choices. It's gonna save it to a folder. In other words, it's just gonna save all the parts and pieces to a folder and make sure that everything stays together. What I would recommend is that you flatten it to a zip, save to zip. That means all the parts and the assembly go in a zip file. That's what you would upload to me. Does that make sense? So this is by far the better choice. It's easier to email than a folder. right? Full of things. I mean, if you think about assemblies are gonna get, you're gonna have 20, 30 parts in your final project kind of thing. It's a management problem, let me tell you, especially when you go change a part and you don't get that into the assembly and then you try to rebuild and the part's not there and it blows up and it's a problem. So really gotta be diligent about how you're doing this. All right, so then you go save. And that should have done it to that folder, table in class. There it is, right there, the zip file. These are the other ones I did that I did not pack and go. But inside here are all the parts. The one part is within the assembly because I didn't save it separately. All right. Pack and go. Questions?
Once he's done working on for that section.
Yep. Yep, just save it as an assembly as you're working, as long as you got everything in a folder, it won't flip out, right? And then in the end, pack and go it to deliver it, to email it, to upload it to Blackboard, yeah. And then you're gonna want a PDF of the assembly, and you can do that. Get the image the way you want it. And then you can do file, save as. And you can change this to PDF. There. Give it a new name if you want. I usually tag it with PDF, just so I remember. It's going in the same folder and hit save. And it's gonna look like this, which is fine. That's all I need, because I do want a PDF. Also, there it is. See what it looks like. What it looks like. Looks fine. Okay. I don't want to upgrade. Not now. Oh boy. Questions? Build your parts. Build your assembly. Good luck. If you need help, I'm here.